Welcome to Math TV with Professor V. In this video, we're going to learn how to use series to evaluate limits. And when I say series, I mean infinite series. In particular, when this kind of problem pops up, you usually have to use a Maclaurin series. So try to break it down into 3 basic steps that you can follow anytime you have to tackle one of these problems. The first thing is you want to identify the term or terms in the limit that you can replace with a known Maclaurin series. And I just pasted in some known important Maclaurin series that typically will come up in these kinds of problems that you should have studied already in this topic, in this lesson. Then the second thing you're going to do is write out the first few terms of the Maclaurin series. Typically, when you're working with the limits, you don't want to use the sigma notation version. You want to use the expanded version. And then you can put plus ... in the limit. I'll show you exactly how it's all going to work. And then usually these problems have been constructed in such a way that terms will cancel and simplify really nicely. You'll see while we work through some examples. So just simplify your little heart out and find the limit. All right. This is just there's a small set of exercises that have to do with this topic, and it always kind of stumbles students, but it's not that difficult. It just takes a little bit of practice. So that's what we will do right now. Get out your pencil and paper and join me. Okay, let's have a little math party. So the directions will usually say use series to evaluate the limit. Obviously, if I had it my way and the directions didn't say use series to evaluate the limit, I'm looking here. I have an indeterminate form 0 over 0. I would probably just use L'Hopital's rule, and take the limit directly. But part of being a successful math student entails following directions. All right, so we're going to use series to evaluate the limit. So first step was find the term or terms that can be replaced using a Maclaurin series. So I'm noticing, ln 1 plus x. Go back and look. Yes, that is a known Maclaurin series. Now, what if you don't have these basic Maclaurin series memorized? Then you're stuck, okay? So make sure you put them all to memory, or at least know how to derive them. Like quite a few, sometimes in a pinch I'll derive this one, but when I'm working, I memorize it. Okay, so off to the side, watch what I'm going to do. I'm just going to list out the first few terms of natural log of 1 plus x. Like I said, in the limit, we usually don't want to work with the sigma notation version. I'm going to use the expanded version and just put some ... So we've got ellipses. I know what they're called. I just like saying ... okay? So x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus ... I love it. Okay. So we're going to go, take that, replace it where we have natural log 1 plus x in the limit. You see? Yes, we see, Professor V. Oh, good job. Okay, limit, x approaches 0. X, I didn't mean to change colors there. The perils of being left-handed. Okay, x minus, and then all of that goes in parentheses. So x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus, keep them ... going, over x squared. Beautiful. And then look, I told you something would always cancel in like a cutesy kind of way. See how this x cancels with this x here? And then be careful because this minus sign will distribute and change the signs of all of the terms that remain. So I'm going to list out some more. So here we go. We've got limit, x approaches 0. Now this is going to be positive x squared over 2 minus x cubed over 3 plus x to the 4th over 4. Let me just write out a couple more. What would be next? Minus x to the 5th over 5, right? And then plus ... over x squared. Now what to do here with this over x squared? Well, basically you're going to split it up and write x squared under each of the terms here and simplify. You can do it in your head, but basically what we're doing is we're going to divide this guy by x squared, this guy by x squared. Everybody gets an x squared, etc. All right, so then let's see what's going to result. we'll have the limit as x approaches 0. Now in this first term, these x squareds will just cancel out completely. So all I have left is 1/2. Minus, now when you cancel here, this x squared's gone, but this is going to be to the first. So minus x over 3 plus, again, this is gone. Now this is going to be x squared. So that's going to be x squared over 4 minus, do you see what's going on? This will be x cubed. Yes, okay. X cubed over 5 plus blah, blah, blah. Now notice, all of the other terms after minus x over 3, everybody from here on out has an x in the numerator and just a constant in the denominator. So if I use direct substitution and plug in that x is going to 0, well, this term's going to go to 0, this term's going to go to 0, right? You just have 0 over some number. All the rest, they go to 0 too. So who's remaining in this limit? Just this positive 1/2 here, ba-dum, ba-dum, and there we go. Okay, how was that? Not too bad, right? I hope it wasn't too terrible. Okay, let's try another. Like I said, you just got to practice these and then they get super repetitive. They really do. So, example number 2, we have the limit as x approaches 0 of sine x minus x plus 1/6 x cubed over x to the 5th. So first things first, identify which term or terms can be replaced with a Maclaurin series. So you just have to know that table. You're on the lookout for typically e to the something, sine of x, cosine x, tan inverse of x, natural log 1 plus x, or 1 plus x raised to some power. Okay, it's going to be sine x, right? Do you remember the Maclaurin series representation for sine x? So I just think to myself, sine, we know from trig, sine is an odd function. So it involves x raised to odd powers divided by the corresponding odd number factorials, and it's alternating. All right, so sine of x is x minus x cubed over 3 factorial. It's alternating, so then it's going to be plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. So that should be enough to get the ball rolling. We are going to replace sine x in the limit with the first few terms from its Maclaurin series. All right, good. So here we go. We've got the limit as x approaches 0. Let's write it out. We have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot 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 minus x plus 1/6 x cubed. Oop, I need a little more. There we go. And then over x to the 5th. Okay, anything you notice we can cancel out? Yes, look, this is x. We have a negative x. Beautiful. 3 factorial. 3 factorial is 3 times 2 times 1, so that's 6. So I have negative x cubed over 6. Here's positive x cubed over 6. Those cancel as well. Oh me, oh my. And that looks like all the cancellation I can do in the numerator. So now we've got limit, x goes to 0. Let's see what's left up top. X to the 5th over 5 factorial minus x to the 7th over 7 factorial. Should we write a few more? Plus x to the, you don't have to. I find it therapeutic at times, that's all. Over 11 factorial over x to the 5th. And then now you should be getting memories of the problem that we just did a couple minutes ago. It looks pretty much identical. You're obviously just going to simplify and cancel out x to the 5th from each of the terms in the numerator. At this point, we're advanced, so I am not rewriting x to the 5th under every little term. You're in Calc 2. Suck it up and let's just do it mentally, okay? Yes, we can do it. Hold yourself to a high standard of excellence. All right, so now we're going to have 1 over 5 factorial minus, this will be x squared over 7 factorial. I'm just canceling out the x to the 5th from the numerator mentally. Ooh, x to the 4th over 9 factorial minus x to the 6th. That's enough. That is certainly enough. Same thing as before. All of these terms right here, forever onward, will have x's in the numerators, constants in the denominator. So as x goes to 0, yes, this goes to 0, this goes to 0, everybody goes to 0. Do one for the dot, dot, dots. They go to 0 too. All I'm left with now is 1 over 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So this is 1 over 120. Oh, are you getting the hang of it? They can get a wee bit spicier, okay? But I'll save those for like the end. I think you guys can try this one on your own. I really do. Why don't you pause the video and see if you can knock this one out? Okay, did you pause the video? I certainly hope so. Otherwise, you're just cheating yourself. Okay. So what term can be replaced with the Maclaurin series? It's the tan inverse of x. So let me write out the first few terms. Tan inverse of x. We don't need the sigma notation version. So it's just x minus. So tan inverse, this is how I remember. It looks so much like sine. It just doesn't have the factorials in the denominator. And why does it look like sine instead of cosine? I just go, oh, because tangent's an odd function. I mean, that's not really why, but that's just how I remember. Okay. Now, there is a 3 in the front. That's fine. Don't have a panic attack. You're going to put parentheses around all of this when you replace it for tan inverse of x in the limit, and you're going to be fine. Okay. It's like too aggressively dark of a purple. Okay. So here we go. Limit as x goes to 0. Here's the numerator. We have x cubed minus 3x plus 3 times x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus yada, yada, yada over x to the 5th. Okay, now from here, let's see, shall we start distributing and then canceling? It's up to you. It's just how good is your mental math? I could probably start canceling now, but I don't want to lose anybody. So let's just take it one step further. So this is x cubed minus 3x plus, I'm going to distribute. Are you ready? Yes, we're ready, Professor V. We're so thrilled to do this. Good, 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 good. So we have plus 3x minus, now those 3's are going to cancel, so we just have x cubed plus 3/5 x to the 5th minus 3/7 x to the 7th. Oh me, oh my, I have run out of space. What would be next? You know, I just like one more term. Plus 3/9 x to the 9th minus blah, blah, blah. Good. Over x to the 5th. Good. Okay. Anything wild happening? X cubed cancels. 3x cancels. And at this point, you should be like, oh, this old scenario. Limit x goes to 0, 3/5 x to the 5th minus 3/7 x to the 7th plus 3/9 x to the 9th minus blah, 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 dot, 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 over x to the 5th. We've been here twice already. So now it's time to just simplify, divide everything in the numerator by x to the 5th. Will it always work out this way? Yes, because someone sits there and artificially manufactures these limit problems, okay? I know. Minus, this is going to be 3/7 x squared plus 3/9 x to the 4th minus blah, blah, blah. And then as the limit, as x goes to 0, we can see that these terms onward and all of the rest encapsulated in the ellipses will also go to 0. So all we're left with is 3/5. You know, this is why I always believe in doing homework. a good amount of homework because perfect practice makes perfect. And by now we've done 3 of these, and I'm sure you're feeling a lot better than after we did the first one, just because you see the process over and over and over, you know? Okay, now I told you it was going to get spicier, so here we go. Use series to evaluate the limit. Which terms can be replaced with a Maclaurin series? In this case, we have 2. Oh, wow. Cosine of x as well as e to the x. Okay, so let's list them out off to the side before we get rolling, all right? So cosine of x, cosine is an even trig function. So I just think of it, it's all even powers on the variables and even factorials corresponding in the denominator. It's also alternating, so it's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Also, if you take the derivative of the Maclaurin series representation for sine, you get cosine. Isn't math just beautiful? Okay, and then e to the x, it's basically absolute value, so no alternating sine plus cosine. So everybody, odds and evens, all together, living in perfect harmony. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x. Okay, that's enough, right? Yeah. We could go on forever, literally. Okay, so we're going to replace both cosine x and e to the x with this expanded version of their Maclaurin series, okay, in the limit. So now we have the limit. X approaches 0. Let's see what's going on in the numerator. 1 minus, let me switch colors for your learning pleasure. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus blah, 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 over 1 plus x minus, and then now e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, excuse me, etc., etc. Okay, by now you should be old pros. It's just this one might make you nervous because, you know, you've got stuff going on, infinite number of terms in the top and bottom, but don't fret, we got this. The ones cancel out, yeah? Okay, just make sure we distribute the negative now. So here we go. In the numerator, I've got x squared over 2 factorial minus x to the 4th over 4 factorial plus x to the 6th over 6 factorial, etc. And then what about in the denominator? Okay, look, the 1 cancels, the x cancels, and then now I'm also going to distribute this negative. So what do we have here? A negative x squared over 2 factorial minus x cubed over 3 factorial. Everybody's negative now in the denominator. Blah, blah, blah. Okay. Now, in this case, we don't just have one term to cancel out from the denominator, right? And typically, when you have this kind of setup where you have variables in the numerator, variables in the denominator, you just want to divide out or cancel the greatest common factor. So I can't take out any more than x squared from these two terms. So that's what I'm going to divide everybody by. Not the highest power of x in the denominator. You only do that for limits that go to infinity. In this case, I'm just going to cancel out the GCF. I can divide out an x squared from everyone. So it's kind of like the lowest exponent, even though it is the greatest common factor. That's the biggest I can take out from everybody, which happens to be the smallest power on x. I know math terminology can be confusing. Okay, so let's see. If I divide everybody by x squared in the top, I'm going to have 1 over 2 factorial minus x squared over 4 factorial plus x to the 4th over 6 factorial minus blah, blah, blah. And then in the denominator, let's see, I'm dividing everyone by x squared. So negative 1 over 2 factorial minus x over 3 factorial minus x squared over 4 factorial minus a bunch more terms. And now here we're pretty much done. So as x approaches 0, this is just a constant, this is just a constant. All of the other terms have x in the numerator and a constant in the denominator. So as x goes to 0, all of the other terms will be going to 0. And I don't have an indeterminate form. No, I don't have 0 over 0. I have 1 over 2 factorial over negative 1 over 2 factorial remaining. I don't have to write lim anymore. I have no more variables here. 1 over 2 factorial divided by negative 1 over 2 factorial. Why, that's just negative 1. Okay. Now, I did mention, sometimes, or most of the time, if they didn't tell me to use series to evaluate the limit, we could do it much more easily. It's 1 minus cosine x over 1 plus x minus e to the x. So if you want to check that you did it correctly, let's see. Let's see if using our old methods it would come out quicker. 1 minus cosine x over 1 plus x minus e to the x. I think this one will be nice to use L'Hopital's rule. So if you try direct substitution, you have 1 minus cosine of 0 is 1 over 1 plus 0 minus e to the 0 is 1. We have 0 over 0, so we can use L'Hopital's rule. So this is the limit, x approaches 0. Derivative of 1 is 0. Derivative of negative cosine x is positive sine x. Derivative of 1 is 0. Derivative of x is 1 minus, this is e to the x. Can I plug in 0 for x? I'm going to have 0 over 1 minus 1. Nope, no good still. So one more L'Hopital's rule iteration, and I think we should be good. So now in the numerator, we have cosine x over derivative of 1 is 0, negative e to the x. And now if I direct substitute, I plug in 0. Cosine of 0 is 1. Over negative e to the 0 is 1, so this is negative 1. Oh, cool. So why aren't we just using L'Hopital's rule? Because did you read what the direction said? The direction said use series to evaluate the limit, so that's what we're going to do, okay? Don't question it, just do it. Sometimes it does make it easier. Some of the earlier problems, L'Hopital's rule would have been nightmarish. Don't believe me? Go try it. I waited until this problem to show you L'Hopital's rule worked for a reason, because it wouldn't have been so cute on this one. It wouldn't have been so fab on some of the others. Do you get what I'm saying? It would have taken like so many iterations. It could have gotten gnarly. I waited to show you that this was an alternative method on this guy because it came out nice. Okay, so one more, and then we'll call it a day. This one is on my practice test for my class. I'm going to do shameless plug. If you want more worksheets, practice exams and stuff, it's all on my Patreon. So if you want to sign up, the link is in the description. There's different tiers, but mainly 2. So the basic one will give you pretty much everything you need. Okay, use series to evaluate the limit. Ooh, so which term or terms are we going to replace with the known Maclaurin series? It's the e to the negative 5x. And you might be like, wait a minute, Professor V. We do not have a Maclaurin series for e to the negative 5x. Well, you do, sort of. So you know e to the x, or you should, is the sum n equals 0 to infinity x to the n over n factorial. And then expanded, we know what it looks like. So if you have e to the negative 5x, you're just going to come through and replace this x here with a negative 5x to the n, okay, over n factorial. And then you do want to keep in mind that negative means it's going to be an alternating series. So you pretty much have negative 1 to the n, 5 to the n, x to the n over n factorial. And I'm going to list out the first few terms right now, so we're ready to go. So if n is 0, it's going to be 1. If n is 1, it's negative 5x over 1 factorial plus then 5 squared x squared over 2 factorial minus 5 cubed x cubed over 3 factorial, etc. And that should be good for our purposes. All right, so then let's see what we have. We have now the limit. I put this as extra credit on the final or on one of the exams. It seems familiar. Okay. instead of e to the negative 5x1 minus 5x plus, let's write this as 25x squared over 2 factorial minus 125x cubed over 3 factorial, plus dot, dot, dot. And then these guys just come along for the ride. So minus 1 plus 5x. Most likely they'll cancel. That's how this has been going, over x squared. Oh, indeed they do. Look, minus 1 plus 1. Minus 5x plus 5x. Goodbye. And then who's left? Oh, this is just like all the other problems we did. Wow. 25x squared over 2 factorial minus 125x cubed over 3 factorial plus blah, blah, blah. Honestly, that's enough over x squared. You're going to divide out x squared from everybody who's left. And then we'll be done. So limit x goes to 0. This is 25 over 2 factorial minus 125x over 3 factorial plus, well, the next one, you don't have to do a next one. I'm just feeling inspired. 5 to the 4th x squared over 4 factorial minus blah, blah, blah. And then again, as x goes to 0, this term goes to 0, this term goes to 0. All of these guys would go to 0. Only lone survivor is 25 over 2 factorial. What's 2 factorial? 2 times 1? Yes, so it's just 25 over 2. Ba-doop boom. And we're done. And that concludes the video. I hope you enjoyed it. Give it a thumbs up if you found it helpful. Share it with your friends, your classmates. Give me a subscribe and hit that thumbs up button. It really helps support my channel. And if you would like to see more content, check out the rest of my YouTube channel. I have everything organized into playlists. I have full-length video lectures for all of Calc 1, 2, and 3. If you want to see what I'm up to on the daily, you can follow me on Instagram and TikTok at MathTV with Professor V. And I hope you have a great day, you guys. See you soon.